Everyone, I'm Kelsey. I'm a OpenSciEd teacher and facilitator. This video is going to go over lesson 10 in unit 6.2. So how do we get here to lesson 10? In lesson 9, we had the water bath lab. And from the water bath lab, we figured out that when the temperature of a sample of matter in one system decreases, the temperature of the matter in the neighboring system increases. When the temperature difference between the two neighboring systems is great, more energy transfers between them, and hot or cold can move through the wall of the cup system. After all that, we are left wondering, what's the difference between a hot and a cold liquid? And that's what we will investigate in this lesson. Here's a lesson at a glance. So this is an investigation lesson. It's 2 days long. We have 20 minutes of material prep. We do have a hands-on investigation. We do not need devices, but we do have a video that we're going to show the students. It's called the dissolving candy video. Here's a lesson at a glance. So we can look at this lesson as having one sense-making loop. After the last lesson, we weren't sure if with a cold liquid that warms up over time, is the coldness actually leaving the cup or is heat coming into the cup? So we start by making some predictions around that. And then we do three things. We watch a video of candy dissolving in three different temperatures of water. Then we conduct an investigation ourselves by putting food coloring in three different temperatures of water. And then we finally have a reading about a historical scientist who investigated the same thing, but in a different way. So we make sense of all of these sources of evidence, and we determine that particles of colder water move slower and particles of warmer water move faster. So we figure out that the movement of particles is related to the temperature of the water, with particles in colder water moving less than particles in hotter water. And this leaves us wondering why. Why do particles move more in hot liquids? I'm going to highlight one key moment in this lesson. That's part 7, where we're making sense of multiple sources of information. So again, the three sources of information that we are working with in this lesson is the dissolving canning video, the food coloring lab, and the reading. The lesson question is, what is the difference between a hot and a cold liquid? From these sources of evidence, students can clearly see that hot water is moving faster than cold water. So that's one of the goals of this discussion, is to kind of get that big idea out there. We also want to develop a particle model to show these faster or slowing moving particles. In this example, we have shorter and longer arrows showing more or less movement. Lastly, we begin to think about how energy might be involved with this, but we're not introducing the term kinetic energy yet. But briefly talking about this with your students at this point is going to help drive the thinking to the next lesson. Okay, again, I have one material management tips and trick for this lesson. So the food coloring lab, this is an oldie and a goodie. I highly recommend it. When I ask my students what's something we did that really helped you learn, a lot of them talk about this lab. It's very visual. So I really recommend doing it in tandem with the other activities in this lesson. But my only tip here is to use dark colors. If you use something like yellow food coloring, it's not going to be as easy for them to see the movement as if you do with darker colors like blue, purple, things like that. So that's my only tip. We do not add any words to our word wall in this lesson. We do create a poster. That is the new model that we are creating about particle movement. We are going to add to this model in the next lesson, and I always put this on the wall after that point for the remainder of the unit. So this is definitely an important poster that we're creating. And that's it. In the next lesson, we're going to investigate, why do particles move more in hot liquids? And that will be the next video. See ya.